Thank you very much, Victoria. And I will quote one thing from Victoria's speech, that we need to act. We all need to act to implement a decarbonization roadmap. Our second keynote speaker will be Dr. Salah El-Haggar. Please welcome with me Dr. Salah El-Haggar, a professor of energy and sustainable development at the American University in Cairo, president of the Green Building Council, and the president of the conference. Please welcome him on the stage.
Thank you, Yasmin. Good morning, everybody. Today, inshallah, I'm going to talk about a proposed, if you remember yesterday, I said most of the presentations in this conference are case studies. But this one here, it is not a case study, it's a proposed case study. It has been implemented in a pilot project somewhere all over the world, and we'll see why it is not yet commercially available. It's a proposed case study for net zero emission. The agenda, again, as I mentioned yesterday, I will talk about what is net zero in a global scale. I will repeat it again because I know some of you might not be here. Some of you was not here yesterday, and therefore I will give an overview about this in different formats. And then I will focus mainly on net zero emission proposed case study. At the end, I will give a conclusion and recommendation. Now, the objective of today's presentation is to present the core concept of the net zero in general, and then to present the solution of global climate change using net zero emission strategy through a business plan. Now, this is, as I mentioned before, this is the only book available worldwide about net zero emission, which talks about net zero in a global scale, like net zero water, net zero energy, net zero waste, net zero carbon, and at the end, all this here will end up by net zero emission strategy. And the most important part is the net zero green strategy. And that's what's already, declared in COP26 in Glasgow. Now, the main idea behind this book, as I said yesterday, is to see why sustainability is not implemented as it was planned in the Earth Summit in 1992 in Rio de Janeiro. The answer for that, it is the lack of innovation, and innovation in sustainability related to net zero. Now, net zero green strategy, that is a global scale. That is the global scale. Each country should have a net zero green strategy. What we mean by that is to have in equal out. What's in, it's the raw materials, energy, water, and raw materials. What's out, it's the products and emissions and waste. We have to think about waste and emission to be utilized, not to be treated and disposed. And that's a key issue behind sustainability. Treatment is totally against sustainability because you are spending money, but you are gaining nothing. Now, this net zero waste strategy, I will talk about it, or we will have two sessions today, by the way. We will have two sessions related to net zero solid waste, and another session which is related to net zero wastewater. And I think this slide will be explained in detail with a lot of talks in the two sessions. When we talk about net zero wastewater, we always talk about, the way to convert all our waste into a high-value water to be either used for landscape irrigation or for some other purposes. And this will be discussed in detail today in one of the sessions. As I said before, net zero energy, people always try to talk about net zero energy. There's a difference between net zero energy and net positive energy. We have a number of projects all over the world with a net positive energy to generate energy, not only to run the building or the community, but also to run the building or the community, and the rest will be transferred to the national grid. And we have a lot of projects worldwide, by the way. And there is a prerequisite for that. The prerequisite is to have energy saving energy saving from the beginning. Energy saving by insulating the building envelope, and by using the natural lighting, by also using the high performance glass windows. All these kind of elements will reduce the energy up to 60 to 65%. And then the remaining energy will be just supplied by renewable energy. Of course, I mentioned yesterday we have the PV cells, which most people try to say this is expensive, but we have also another project which started 2015, and I think it will continue using the macroalgae as a biomass to generate electricity or energy and other products. And this is the future, by the way. This is the future because the cost of this biomass windows will be almost 50% less than the PV cells. Over and above, it will allow the natural light to get into the building. Neutral carbon strategy, most people try to say neutral carbon is very expensive because sometimes you have to spend, you have to emit some carbon emissions, but in the same time you have to develop something to absorb the carbon emission or the greenhouse gases, either by green fields or by something else. What I mean by something else, that's what we are going to discuss, inshallah, in this presentation. And at the end, you will end by net zero emission. As Victoria mentioned, we have to have net zero emission by 2050, and this is a mandatory for the whole planet. This is a very important diagram here. If you have a power plant, this power plant will burn fuel, and for the worst condition, say we are going to use the lowest quality coal worldwide, or mazut, heavy oil. Now, in this, either mazut or coal with high sulfur contents, it will emit sulfur oxides. Now, at the beginning, you have to have some kind of desulfurization unit to utilize the sulfur oxides. And to utilize the sulfur oxides, all you have to do is inject lime, which is calcium hydroxide, react with sulfur oxide, and produce gypsum. And then you can utilize the gypsum in too many applications. And one of the first projects started in Europe, it was in Denmark, which is Jebrock, which they produce gypsum pores out of that. And then after that, the other emission, which is CO2 and nitrogen oxides, because when you burn any fuel, you have nitrogen oxides and carbon oxide and sulfur oxides. If you don't have sulfur oxides like natural gas, then this desulfurization unit will be removed. But the worst scenario is to have this sulfur oxide. Now, carbon oxides or carbon dioxide and nitrogen oxide is considered as a nutrient to macroalgae, because microalgae is a very, very promising biofuel for the future. By the way, biofuel is the it's the main alternative fuel as a renewable source of energy. In this case here, you are going to utilize the solar energy with the CO2 through a photosynthesis process and grow macroalgae. In the same time, nitrogen oxide will be considered as a nutrient for the macroalgae. And then once you produce the macroalgae, then you will have oil extraction unit. The oil extraction unit will take the oil and convert it into a biodiesel. By the way, right now in Europe, they use 10% biofuel in all diesel engines. Why? Because two things. Because it will enhance the combustion efficiency and also will reduce the emissions. In other countries, they try to increase the percentage of biofuel to, again, approach net zero emissions. And then the waste of after extracting the oil, the waste of the macroalgae will go into anaerobic digester and produce a biogas. Then from this system here, you have a liquid fuel and the gaseous fuel, which can be utilized. One case study which was demonstrated, I think about 15, 16 years ago in the United States, they have this kind of a pilot project. And I will explain the details of that, inshallah, today, where they have a high percentage oil macroalgae stream. Just to give you some kind of idea, macroalgae there's almost too many strains for macroalgae. There is strains which has high percentage of protein, strains which has high percentage of oil, strains which has high percentage of carbohydrates. And therefore, they try to, produce a certain percentage of 70% of oil, and this is still classified between British Petroleum and Shell Oil and Gas Company. As I said yesterday, macroalgae is the future. It has a lot of applications. Just to give you some kind of idea, in Egypt, we have almost 15 macroalgae ponds all over the country. And we have one natural pond called Green Pond along the Cairo-Alexandria Highway somewhere in the middle, where macroalgae in this area, it's a spirulina. And National Research Center, they harvest the macroalgae from this green lake, and they process it, and now you can buy all types of product in the National Research Center, and they have a center for that. They have almost about 15 products out of it. And therefore, there is a market for the macroalgae. This is a very important table here. This table, by the way, it's a collection of a lot of data in the United States, funded by Energy Department, where they, of course, in the United States, they use corn as a biofuel. And what's mentioned in the third column here, that is the required land to cover 50% of the required energy in the United States. The first one is the corn. Another line, which is the last line, is the macroalgae with 70% oil content. The last two columns are macroalgae, one of them which is 30% oil content, which you need only 2 megahectare to cover 50% of the required energy demand in the United States. The last one, which is a macroalgae, which is 30% oil content, which is available in the local market right now, which is Donaniella, which will require 4.5 megahectare per hectare to cover 50% of the demand of energy in the United States. One thing which is very important to mention here, palm oil. In Malaysia, they start growing palm oil. First, to cover the national consumption of palm oil as an edible oil. And then after they exceeded the national consumption, they start, exporting palm oil all over the world. And now they are converting palm oil into a biofuel. I know there is a concern from some of the green experts in Europe against this kind of idea, because in Malaysia they found there is a big market for palm oil, and therefore they tried to replace the national forestry by palm oil forestry. Again, I'm not talking about the politics here, but in Malaysia they have planned to have palm oil as an alternative fuel before 2050, by the way, which is net zero emission alternative fuel. That is a macroalgae farm. In conclusion, utilization of greenhouse gases is the key issue behind solving the climate change problem. Macroalgae, it has a lot of applications, not only as an alternative biofuel, but has a lot of industrial applications. It can be used as an animal as an additive to the animal fodder, as a food for human. In some countries, they use macroalgae as a main dish, like in a Chad, for example, and also has a lot of application in cosmetics, in industrial activities. Enhancing national economy in Egypt and Africa through macroalgae farm. I think macroalgae is very simple to grow as long as you have enough solar energy and carbon dioxide. And in conclusion, this example here will contribute to the 17 Sustainable Development Goals and will maintain 1.5 degrees C or less as the temperature difference as stated in Paris Agreement. And this is the road to approach net zero. My last word, net zero concept is a solution, and I mentioned that and repeat it again today, is the solution to all pollution problems, including climate change. And it will accelerate the implementation of the 17 Sustainable Development Goals. And again, try to keep this in mind. Utilization is the solution to pollution. As I mentioned yesterday in the panel, environmental sustainability means you have to convert all types of pollution into a business plan. And this is already done all over the world. Almost there is 20 years of experience all over the world to convert all pollution problems. And I remember Nelson Namiro, one of the experts in the United States, he gave a speech almost about 20 years ago. He said the only solution to pollution is utilization. Thank you.